Thanks for coming here today. My name is Matt Yanchishin. I've been talking about big data at AWS for many years now. I've been with AWS for almost 4 years. And today we're going to follow on what we were talking about earlier with a conversation about streaming data and a deep dive into Kinesis. The point of this is that let's level set. What does streaming data mean? What type of data are we actually talking about? Generally speaking, these days it means some kind of messy JSON. Today we're talking about streaming data, which is typically like information, logs. And in this case, you could have a metering record, MQTT, which is a way of writing data and a protocol associated with it that is more lightweight, that is used in a lot of IoT devices, like our AWS IoT service. Most commonly, probably syslogs or common log entries. That's an Apache log right there, following the standard Apache log format. This is a syslog, like a Linux, Unix syslog. What I'm seeing a lot of, I work with large software partners. I'm seeing a lot of oil and gas firms now, manufacturing firms, both in an IoT context and just they have sort of smart pipes and stuff in the oil industry. If you think of your home electrical meter, these smart meters are not because the electrical companies actually love you, it's because they're getting massive subsidies, and those subsidies are contingent on rolling out smart meters to the American household. So the smart meters is one where we're seeing a lot of streaming data. Increasingly, we have connected devices in our hands, in our houses, on our pipelines, everywhere, and you need some way to collect that data. And what was a few megabytes or kilobytes or even gigabytes a year or two ago is now suddenly petabytes. And it's actually a real fun and hard problem in terms of how you collect that data at scale and how you do it in such a way that when your business blows up, when you're like a Sonos, for example, a successful company, and suddenly everyone's buying your stuff and you're a little company, how do you do an architecture that you don't have to redo in 6 months when your product blows up, such that you can handle that inbound scale and also process it at scale without blowing the bank? Saji and I and others work with a lot of companies who are kind of victims of their own success. They have all this data flowing in, or they've acquired a company that has a massive trove of data sitting on, in the case of one company in Connecticut, sitting in containers on their front yard, and they're literally out of grass to hold the containers with the tapes. And they don't know how to handle that static data, let alone all the streaming data coming in at them. So here's some industry use cases, some of the stuff I was just talking about. Seeing a lot of sensor stuff. Also just clickstream data. Even if you're a web designer, if anyone's into graphic design or web, you'll know that the days of kind of boring static websites are over, and the days of having just a simple bug are over too. You're now doing advanced telemetry. I'll give you a specific example. You can actually sell ad space on more advanced websites based on where people are swiping or clicking or where their mouse are. And there's whole companies that have built their business on sort of that type of telemetry. Where are the hot spots on a mobile app? Where are the hot spots on a website? You can actually sell ads in real time at higher rates, which fluctuates depending on how people are using the mobile app or the website. That's a lot of streaming data. That's just not a little transparent pixel in the top right. That's a lot of advanced sort of JavaScript that's pumping data somewhere, and it has to go into a back-end system, and you have to be able to process it quickly so that you can sell that ad in time to still capture the user while they're engaging with your app or your website. Increasingly, advertising on the streets. We work with a company now called Intersection, used to be called Control Group. You may know them from the New York City phone booths that they've converted into high-speed wireless internet that we can profit from now. They also do kind of smart advertising. So we're seeing this across many different industries, many different applications. It's not just limited to kind of log processing, but that's how most of us start, and quite frankly, that's like the bulk of the work we're doing. We talked about a few different use cases. How does that map kind of on a high level? More often though, it comes down to alerting. You know, if any of you are in operations and DevOps and you have telemetry really now in your applications where you have alerts happening based on data feeding into, say, CloudWatch. CloudWatch is a good streaming data application, or we have our friends from CloudCheckr. Like anything that's sort of monitoring the state of your infrastructure, of your cost spend, of how things are going and taking actions accordingly is processing streaming data. And then there's microbatching, and this is something that we're still sort of seeing emerging, but increasingly now, big data analytics, and to talk in the analytics, is more about streaming data than it is about batch processing. And it's sort of a lie to say streaming. What it really is microbatching. Like if you think of most people doing streaming big data analytics, they're actually chopping the data into little discrete pieces and microbatching because it's inefficient. For example, if you have a less than 1 kilobyte JSON record, right? It would be inefficient to do big data processing over that. It's much more efficient to compress a bunch of those together and have little chunks and then store them on, say, S3, and then iterate against them and do real-time streaming. So the efficiencies you get in scale and architecture are much better than the reverse when you have to allocate, say, a worker in a Hadoop cluster to every single tiny little JSON piece. So that's what microbatching is aggregating collections of little teeny tiny bits of data so that you can operate on them. And it looks like streaming, but it's actually little micro batches. In fact, Spark is a good example of something, Spark Streaming, that uses that approach. So let's jump right into some architectures. And I'll pull back from this in a second and go through the different components and focus on Kinesis. Here's a really sort of everyday streaming use case. And it's hilarious because this is now like every day, whereas 2 years ago, people have been like, oh my God. You know, whereas this is now pretty, not, I wouldn't say run of the mill, because it's not like every company is doing streaming data processing, but this is much, much, much more common. So here we have some kind of a web front end. The easiest way to deploy a web app, other than the serverless way that Saji just described, which is my preference, is to throw your WAR up on Elastic Beanstalk and have us handle the scaling and the rest. And then it's pushing data into Kinesis streams, which we're going to focus on today. And you can think of Kinesis really just like a giant queue, but it's different from SQS, and it's really designed for handling streaming data rather than just arbitrary sort of chunks of data that you'll pick up in a sort of a typical queue use case. It's more for streaming data processing. And then from Kinesis streams, it's getting processed in Hadoop, in this case, Spark. So we're running Elastic Mapreduce, EMR, and we're running Spark streaming on Hadoop. Going from here to here, we're going to talk actually about a couple ways to get it from the front end to streams, but we're going to, you can use things like Log4j. I use like a Kinesis sort of aware Log4j pusher. You can use the KPL and write your own application. There's a lot of ways to get stuff into Kinesis. Increasingly, third parties are Kinesis aware. Saji just talked about event-based serverless computing. Well, this paradigm is actually applying to streaming data too. It's no longer good enough to say as streaming data comes in, kind of have a constantly running data processing layer. Sometimes that's inefficient. You don't want to pay for, say, EMR all the time. What if you only care about data when it's interesting to you for that particular use case? For example, if you're running a security application, you might have some basic checks that indicate that this might be a security threat. You don't want to act on every single log entry coming through and do sort of deep analysis. You want to reserve the deep analysis for something that has a higher likelihood of being a problem. So this is where you could use a Lambda function. And you can actually have Kinesis and Kinesis streams and the events associated with them to sort of fire on different conditions. Think of our IoT service, if you're familiar with this. If a certain condition is met, then you can process the IoT data coming in. You don't want to process all of the data coming from all those sensors all the time. So selective processing and processing it when needed with Lambda is really, really important. This is here what we're actually describing, though, is using Lambda to trigger a push into S3 using Firehose. So streaming, Spark Streaming does some kind of data transformation. Often data comes in from a lot of different sources. You bought that company that uses that other web server, to use a simple example, has a different log format, then your log processing analytics engine breaks. So rather than write a crazy filter for the new log format, you can have Spark Streaming normalize the data and put it all in some kind of a common format in S3 in a way that Redshift doesn't barf all over it. We know that schemas change all the time. Sanji just talked to you about NoSQL and the flexibility of not having sort of rigid schemas. And that's where real-time data streaming, data processing, data normalization comes in really, really handy. You can take any stream from any disparate source, normalize it here using Hadoop at scale, and then dump it into S3 for processing. There's a lot of pieces here to coordinate. So data pipeline, you can think of it kind of like cron as a service and your data coordinator. It can kick off different parts of this architecture at different times according to different conditions or even on a schedule. So for example, if you have some kind of streaming data coming in from different log sources and it hits Kinesis streams, and then you use Hadoop to normalize that data so all the data is relatively similarly structured. You then dump it into S3 and load it into Redshift. You can have data pipeline kick off that load, say nightly or hourly, from S3 into Redshift on a regular basis. And then of course, there's the analysis part. We're not going to cover all this architecture today, but none of this would be useful without someone looking at it, or a human, or a computer, or some kind of algorithm deriving data, or sorry, value from your data. And that's, I think, the part that a lot of us nerds forget about, is we get all wrapped up in Spark and all this exciting stuff like Kinesis, and we forget that we're working for a company that has a business. And I know I forget that a lot. And this part is actually the most important part, is how do you derive value ultimately from the data? What are you really doing here? Are you doing threat analytics to prevent nasty people from doing nasty stuff on your infrastructure? Are you looking for some kind of new insight into your customers' behavior so you can sell new products? Are you looking, the case earlier, for a certain behavior that would cause you to sell a certain type of ad on that particular platform to that user at that very moment. So this part is really important, to be able to analyze both in an exploratory function when you don't know what you're looking for, and in a reactive function that you've already predefined, such as serving the right kind of ad to the right person. And that difference between exploratory analysis and sort of pre-programmed analysis is super important, and I'll get into that later. And it's one of the awesome things about having this kind of decoupled architecture, because often you don't know what you're looking for, and people forget this sometimes. They load their data into a giant Oracle database or into Redshift, and they forget, then they have to write these huge complex queries, and it turns out that that's actually really hard, and the people in the white lab coats who come up with these giant queries are very expensive, and you need to have very easy ways to allow normal mortals to explore your data when it's crazy in a bunch of different schemas, and this is where this piece plus this comes in handy. Here's another one. We talked about microbatching, so same thing. We have some clients with a web front end on Elastic Beanstalk. This time we're using Kinesis Firehose, which is a framework that, really to boil it down, makes it easier to get your Kinesis data into somewhere else. The most common use case is you can push to Firehose, and it automatically microbatches and compresses your data into little chunks, and then forwards them to S3 for you. If you were to do that yourself, think about it. You'd have to write some kind of an application that would take all those little log snippets, those little teeny JSON or XML snippets, and then buffer them. And if you're buffering them, you need somewhere to store them temporarily, so that's a risk, because what if you lose that buffer in midstream, then you've lost that data. So then you have to have high availability at the buffering layer, and then you need somebody to compress it. That's CPU time, which means you have to pay for CPU time. And then you need something that can understand how to push to S3. What if you get like throttling because you're pushing to S3 too much, or you haven't done your keys properly? There's all these things that can happen at scale. Everyone's like, oh yeah, I wrote this thing to push to Kinesis. It's 4 lines of Python. Great. Yeah, but what happens when that box with the 4 lines of Python falls over, or when you're pushing 5 terabytes per second to S3? Suddenly it doesn't work so well. So Firehose kind of solves all those problems. It handles all that hard stuff for you. It's kind of classic Amazon. We always say undifferentiated heavy lifting. Firehose makes pushing stuff into S3 and leveraging Kinesis without you having really to think about it super easy. So it's kind of Kinesis without all the fun, but with making it a lot easier. So that's really what Firehose is handling: the microbatching, the compression, all the other stuff behind the scenes, such that you can get nice little gzips or whatever in S3 that you can nicely load into Redshift. So let's talk about some real customers before we dive in. So here's Glue Mobile with some suspect games, a good customer of ours. I don't know how many of you are Deer Hunter fans. So telemetry in games is a really obvious use case. We're seeing this more and more as games get bigger, like literally when you're wandering around these worlds, and it's actually hard to keep track of what different users are doing in different parts of these virtual worlds. And maybe you have a game that sort of changes over time. And so keeping track of not only how users use the games themselves, so you can improve on the features that are most popular, or maybe pull back development on features that are not, or identify bugs. There's also this whole concept of how do I invest more into parts of like a giant virtual world that users are wandering off into that I didn't really anticipate, or maybe they're building crazy stuff. And so telemetry in games in real time, the idea of games becoming real time and becoming giant worlds is super, super important. It's not just about kind of debugging and feature development like it was even just a few years ago. Even how users are interacting. There's tons of data around usage of applications, not just limited to games, but you see gaming companies and other companies that are involved in illicit things, often being the leading edge for capturing user engagement and behavior. You're going to start to see some really similar patterns. So I know I speak quickly, but hopefully we repeat the same patterns enough times that you'll see that whether it's gaming or oil and gas or your Nest or whatever, the patterns for aggregating and processing the streaming data are very similar across many industries and use cases. So in this case, just like that web front end we had before, you have the clients, and we have 70 million to 2 billion events per day. Good example of a company that's done well, and that guy, the summer intern's Python script from 2 years ago, probably isn't working for them anymore, so they had to move to a better model. So in this case, they're using Kinesis, which think of it like a queue to capture the inbound streaming data. Now they're using Storm instead of the Kinesis client library, or in the other case, Spark Streaming. These are all just different ways of pulling data out of your queue, out of Kinesis, out of your buffer, and processing and modifying it. Which you choose is kind of up to your use case. We don't have time to really get into the pros and cons of Spark Streaming versus Storm versus Kinesis client library. If you want to have a side conversation, I'm more than happy to. All I can tell you about Storm is that Twitter's not using it anymore. They kind of came up with it. Now they've announced some other framework. So Storm is great for certain use cases. We'll get into it separately. But in this case, they're using a framework Storm, Spark Streaming, Kinesis client library, it could be anything, which is running on some EC2 instances to pull out data, do some normalization, and structures the data such that it can be loaded into an RDS database in this case. And they're using the Kinesis connectors, which are a series of libraries that allow you to connect Kinesis to other AWS services, to connect to S3, and in this case, then they're batch loading into Redshift. Now, this is probably old, this architecture. I imagine it's evolved since now. If you remember the last slide, they probably could have replaced this and this with Kinesis Firehose, and they might not even really need this. So things evolve all the time, but the general flow remains the same. You know, you have some kind of like what we call a Lambda architecture here. We have sort of the cold data for long-term analysis with Tableau, and the hot data with a lightweight front end to sort of make real-time decisions on user behavior. So I mentioned Sonos before. So if you don't have a Sonos yet, they're overpriced but so worth it, and they work well with your Echo. If you have one of those, you just have to write a Lambda function, then it works fine. So in this case, a lot of telemetry on your Sonos. It's an internet-connected speaker. They need to know what version you're running. Maybe they want to know how you're using the device, whether you're using tune-in radio more than Sonos or whatever, or sorry, more than Spotify. What volume you have it set on, what your equalizer settings are. If everyone has their bass way up, maybe the bass on that appliance by default is too low. I mean, this is actually really important decisions that can affect whether customers like your product out of the box or not. So they're doing a lot of sort of telemetry and metrics, and they need to push all that data somewhere. So they push it to Kinesis. So in this case, they have a custom collector. So think of it like just a back-end thing running on EC2 on AWS. All these speakers everywhere in the world are pushing to this scalable fleet of EC2 servers running their proprietary software. And then that's actually getting forwarded to Kinesis. We'll get into what this means in a second. And they're using, instead of Storm in this case, or Spark Streaming, they're actually using our Kinesis client library, which is no better or worse than any other frameworks. It's just a way of getting your data out of Kinesis, out of your queue. And they're pushing it to 3 terabytes of data S3. And then they're using Spark to actually analyze the data directly out of S3. The cool thing here is there's no Redshift. Remember Saji was talking about serverless websites? Well, that's just the beginning of the story. What about serverless or temporary server data analysis? Or, you know, I'm increasingly seeing people doing data warehouse workloads with no clusters. We can get into that separately. But you can use Spark to talk directly to S3. And you can have your EMR cluster that you fire up every Sunday night, because on Monday the CFO wants their report on the desk. You fire it up for 1 hour, you read the data right out of S3, and then you shut down your cluster. So you pay for 1 hour of EMR usage as opposed to 7 days a week of Redshift use. That's from another talk, though. And then they're using all sorts of different ways, Splunk, Neo4j for a graph database, Kibana to visualize it. Similar architecture. You have kind of your cold long store, and your hot or faster data for sort of real-time response. Like if a lot of Sonoses around the world are to use the French, crapping out, then you probably want to raise a ticket, and maybe there's a Sev2 happening, a big alert, and your firmware upgrade that you just pushed out wasn't highest build quality. So that's where that hot data comes in really handy. But the long tail stuff, like, hey, what are people really doing with their equalizers? That's not really high priority. You can sort of deprioritize that and attack it on a batch basis. This will make a little more sense in a few more slides, but the key thing to retain here is that think of Kinesis like a queue where you can dump streaming data. The framework that you use to pull the data out of that queue, you can be flexible in that regard. If you've ever heard of Kafka, anyone heard of Kafka? Kinesis and Kafka share a lot in common. They're really quite similar. And so the first takeaway, yeah, Kinesis is like a Kafka-esque queue. And as far as architectures go, you always want to think of your data in tiered ways. Everyone's thought of data before as like how valuable that data is to you. Maybe if the data is not valuable, you put it in reduced redundancy storage in S3. But you can also think of your data, how quickly I need the insights from that data. And that's what this is, and all the other things I just showed you. This is if I need some insights quickly, so higher priority things I need fast answers to. And this is more batch analytics data that I can pull out of Kinesis and process on a less regular basis, on a non-real-time basis. And tiering your data like that is extremely powerful, because then you're not wasting resources for data that you might not really need until that Sunday night. So ads, advertisers, no surprise. You log on to a website based on cookie and a bunch of other data. It's aggregated, and it makes a decision about who they think you are and what you would probably click on and buy. That happens in a split second, or more like 1 to 3 seconds. And companies like DataZoo sit at the middle of all those decisions. In this case, they run essentially like an ad exchange, or they work with ad exchanges, and they are, think of them like the real-time bidding company. And AdRoll is another one. There's a bunch of these big companies that provide platforms for the people both selling the ads and buying the ads, and then the people that the ads are actually about to kind of come together on a platform to all make money at our expense. And so here they have a CDN. This is Flume, which is a log aggregator, a real-time bidding system. These are all collections of servers that may or may not be on EC2. I'm not sure. The logo is EC2, so let's go with EC2. And an ad retargeting platform. Point is that disparate things are all pushing to Kinesis. So again, think of Kinesis like Kafka, think of it like a queue, think of it as a durable place where you can safely store streaming data temporarily while you figure out what to do with it. And then they can replay what actually happened in the bids using an EMR cluster in this case, push the results to S3, and they analyze it using one of our friendly partners that I love called Qubole. Or maybe for some of the cold data that they don't necessarily need to analyze immediately, they archive it. They're using the Kinesis client library, again, to pull the data out of Kinesis and dump it to S3. Here, they're also using the Kinesis client library to push to real-time applications that maybe do some real-time analysis on the bidding. Maybe if the rates, the ad rates are way off and bidding is going way down, you kind of want to know about that quickly and make some real-time adjustments to your ad bid ratios or whatever the metric may be. So this is a really good example of a lot of boxes, but of them tiering their data, how things are streaming through the system, what systems they're sending it to based on the importance of how quickly or in what depth you need to know about that data. In this case, maybe they're not doing like full-blown reporting or analysis. It's just kind of like based on some certain conditions that indicate there might be a problem, they push it to the real-time app. How do you make recommendations not only on a website, but also in a store? And that's also a streaming data problem. These are similar problems to what we're talking about here, is data coming into a Kinesis stream, whether it's from a location-based app or a mobile app. Lambda functions to react in real time based on what is coming into the stream, and you can set conditions, so you only fire off a function if certain conditions are met. And then depending on the conditions, that data either gets cold data, goes to Redshift for sort of deep analysis, or maybe hot data goes into DynamoDB, which in turn can trigger a Lambda function, which can then go off and do something else. So these chained events associated with the streaming data are becoming increasingly common, and the idea that you only do something when you have to is incredibly powerful. In a streaming data context. Just collecting the data is one thing, but real-time reaction and only paying for microseconds of reaction in the form of Lambda functions and not having a cluster sitting around waiting for something to happen is cheap. I tell the true story that I have a streaming data alert in my pocket on my Amazon mobile app, or no, I guess I get a text through Twilio, I think. But if my Amazon bill or my CloudWatch billing alert goes above $5 a month, my personal bill, definitely not my AWS bill. If my personal Amazon AWS bill goes over $5 a month, I get a huge, like a text and a phone call because I use 100% serverless, and I actually run an EMR cluster once a month, but my bill is never over about, these days, $3.53 a month, and I run 9 websites and all this stuff for my family. So when I'm showing all these complex architectures, don't think that they're expensive. What we're talking about here is aggregating or taking in, I don't take in terabytes of data, but it's normalizing data, it's processing data, it's reacting against data at huge scale, but at little cost. So we talked a lot about Kinesis without explaining to you what it is. It's just a place to store your streaming data in a scalable and safe way. So when you have a bunch of, say, servers in a data center or different parts of your cloud deployment, and you need to push all of those logs to a place, and you don't want to lose those logs, and you don't want to have to worry about if you add another 500,000 servers, what am I going to do? Do I need to like grow my giant data collection cluster? This used to be a huge problem for people. Data collection became a big data problem. Data storage of your logs became a big data problem. And it's funny because you were probably analyzing the logs with big data, so it was kind of this, you know, circular argument. So Kinesis provides a way to easily scale both on ingest, on egress and ingress, both on putting your data in and getting your data out in a way that you don't really have to think about it. It does things like sharding, makes that easy. If you've ever worked with any large database, you'll know that sharding is rarely easy in any context. It's high throughput, so you don't have to worry about you know, how many megabytes per second of data you're pushing in. It's really easy. We provide a bunch of libraries on both the pushing in and the pulling out side. We also have a wide partner ecosystem. So I mentioned like, you know, Spark and the associated company, Databricks, Storm, you know, from Twitter. There's a lot of other frameworks and commercial companies that work with Kinesis directly. We work hard. That's my team. And it works well with other AWS services. So if you're using EMR today with Spark to analyze data, or if you're using Redshift tomorrow, if you switch to Vertica, that's cool. Vertica might be a little harder, but it'll still work. And most importantly, it's like almost all other AWS services, it's pay as you go. Kinesis is one of the cheapest things you'll ever use. If you add Kinesis to your bill today, it may go from $3.53 to $3.55, like in my case, and that's like at high volume. Kinesis is a lot of things though now. It used to be just kind of this queue thing. I've been using the term kind of loosely. What I should be saying is Kinesis streams. You can tell I've been at Amazon a while because there's Kinesis other stuff. So Kinesis Firehose, which I'll show you in a second, is awesome because it solves what turns out is a really hard problem, which is putting data into Kinesis. It's easy enough to say, oh yeah, I'll just write a little bash script to push logs in Kinesis, like sorta. But what about the problem if you've ever used Redshift? When you're loading data into a database at all, if you're gonna do just think of a regular MySQL database. If you're gonna do an insert for every single record, that quickly becomes inefficient. There's a lot of overhead associated with that insert. So imagine if you have 1 billion teeny little JSON log snippets per hour. That's 1 billion inserts on your MySQL database. Suddenly your MySQL database capacity has been totally exhausted by crappy little inserts for logs, most of which you don't care about. So there's this concept called micro batching, and you can compress things. So you take a bunch of those teeny little JSON snippets, you whack them together into 1 megabyte compressed chunk. So maybe there's like 100,000, probably more, little pieces of logs in each little chunk, and then you load those chunks in every 10 minutes. And if you can meet your sort of data analysis SLA in 10 minutes, you don't need every millisecond that the little log is coming in. You got to look at where is your value come in handy? How often do you need this data? And then compress and batch it accordingly. And Firehose makes that super easy. So you can tell Firehose, collect my data, buffer it for me safely so I won't lose those little chunks. Wrap it into gzip, make like 5 megabyte chunks, and push it into my S3 bucket, for example, every 60 seconds. That solves a pretty major problem. Whereas before you'd have to have that running on an EC2 instance, and as you were buffering things and batching things, there was always that risk that the EC2 instance, because you were, I don't know, mining Bitcoins or something, and you hose the instance, and you lose that data that you were buffering on that instance. So it solves a data scalability problem when it comes to data ingest. And Kinesis Analytics, which is coming soon, I might be able to show you QuickSight later, but I can't show you Kinesis Analytics yet. Basically think of it as like a SQL layer on top of Kinesis, because this was sort of a problem before. You could actually look at Kinesis streams using Hive, using SQL before, a little known kind of non-secret. But that was a pain. You had to spin up a Hadoop cluster and spin up EMR, and then use the Kinesis Hive connector, and then know how to do that in the first place. And then you could do like select star from Kinesis stream. But it turns out it's actually hard to look into a Kinesis stream. You have to write a bunch of Java or do what I just described. And Kinesis Analytics solves that problem. Instead of having to write an application or use a Spark or something else, you can use our console or our APIs and be like, select star from my Kinesis stream. So why would you ever want to do this? Let me give you a real world example. I think it's there's a joke at Amazon that whenever you say Netflix, you have to do a shot. So I'm trying not to say Netflix, but I think it was Netflix. Where they just wanted to see like the last 10 records in the stream for debugging purposes, which is like a really common use case, right? Like you're pushing stuff into Kinesis, you're not really sure if it's working properly, and you want to see if stuff is going there. So it turns out it's actually kind of hard to do, select star from my stream, limit 10. You can't do that. So you can think of Kinesis Analytics as a SQL interface to your Kinesis streams. What is Kinesis? How is it actually architected? So we use this term shard, and the size of your stream, by pretty much any metric, cost, ability to ingest data, ability to pull data out, number of records you can put in per second, how many megabytes per second you can go in or out of your stream, of your queue. That's determined by the number of shards in your Kinesis stream. What's nice about our way of doing sharding is if you use our libraries, you don't have to worry about the shards. Because normally when you shard the database, that becomes a total headache, because you have to remember that like records from A to N were in this shard, and records from O to whatever were in the other shard. With our libraries, we kind of take care of that for you. So for most of you, you don't have to think about shards, but just understand that a shard is a unit of capacity, really. How fast and what the throughput, both in and out, can be for your stream. So data sources push in through, like any other AWS service, an API endpoint. You do puts into a collection of shards. Things get spread across the shards based on like a key, just like a NoSQL database. Depending on what your key is, it gets put in a different shard. We'll talk about that in a second. And then you pull stuff out. Again, You need applications or libraries that are shard aware because data is spread across multiple shards. And so you need something like our Kinesis library or Spark Streaming or Storm, things that know how to talk to Kinesis and know about shards to take care of that for you, and they can pull data out of the shards. So, and then the last piece is how do you actually process, or where does this data land? You can land it in a bunch of places. We have connectors for S3. Most people, when they're using Kinesis, they push into Kinesis, usually now with the fire hose, and they land it in S3, and then they either load it into Redshift or they analyze the data directly in S3 using EMR with either Spark or Mapreduce or whatever. So that would cover these two use cases. Increasingly, we're seeing people with events, with Kinesis streams and other stuff, process data or do things with the data on the fly using Lambda. Then you don't need a cluster. You can do little miniature data processing or take actions against things coming into your stream using Lambda. And then EMR is our sort of Hadoop as a service or offering, which again can be used to do data processing or data analysis or all sorts of stuff. In terms of what can send in, you can use our libraries, the Kinesis producer library, the AWS SDK, the mobile SDK, Log4j supports Kinesis or some variation of it, Flume does, FluentD. If you're in the ops space, if you're a DevOps dude or dudette, you are probably familiar with these, and all of these can push data into Kinesis kind of natively. And then to pull it out, again, this is sort of a reiteration plus a couple third-party things. Storm works well, Spark works incredibly well. I can tell you personally, if you I'll point you guys, if you want, to a link of a YouTube talk that I gave, or I've given a few times, and we're going to give again in Chicago in a couple weeks, that in about 30 minutes, you can go from knowing nothing to pushing data into Kinesis to pulling it out and transforming it using Spark Streaming to analyzing it using Redshift and Tableau in like 30 minutes, maybe 40. And I'll show you that after. It's not as hard as it seems with all this stuff. So this is an example of how it actually works from a stream perspective. Yeah, so a lot of which I just said. When I said that streams or shards represent capacity, for every shard, you get 1 megabyte per second and up to 1,000 transactions, say, puts per second. And likewise, for every shard, you can pull out 2 megabytes per second. So can anyone guess why the egress, or ability to pull out data, is higher than ability to put in data? Well, because there's this problem. Like, what if you put a bunch of data into the queue or into your stream or to Kinesis, and then like you forget to process it, or you don't want to process it until the spot price goes below a certain rate. So the retention is typically, you're not typically processing data at the same rate going out as you are going in. And also, you tend to process in batch. So pushing data in at 1 megabyte a second steady state, you want to be able to pull out batches at higher rates. So batches less often in bigger batches. It used to be this was 24 hours retention, but now it's 7 days. So this is important. Just think of a server generating logs, and it's generating every second or every 10 seconds or every minute some kind of a log, and then you have multiply that by 50 billion, and you have a bunch of shards corresponding to what that data rate is on the ingest. So you size your stream according to, on an ingest perspective, how many servers and how much data per hour on a maximum you would need, right? And you can set CloudWatch alerts that if you're exceeding or getting near that threshold, you just add new shards. On the way out, though, if they were both 1 megabyte per second, you would have to have a cluster or some kind of mechanism running all the time to pull data out as well all the time. But what if you don't want to, or that cluster falls over? You don't want to lose that data because there's a retention window. And it used to be just 24 hours. And after 24 hours, we would throw away your data. Now, we've since increased that to 7 days, but I should have put an asterisk there because 24 hours is included in the price. But for every hour beyond 24 hours that you store data in a Kinesis queue, there's an additional cost. Now, it's like a Kinesis cost, so it's teeny, but it adds up. If you're smart about it, you can be like, hey, it turns out like 4 p.m. on Sundays, or well, maybe not, don't wait that long, but like every day at 4 p.m., the spot price for EC2, if you're familiar with spot, goes down to like some really low. So I'm going to wait until I do some data processing until that time and then do batch operations 2 megabytes per second and pay less for my processing cluster than I would at 3 p.m. when the price was higher. It's getting a little ahead of ourselves, but like that's a really good use case actually, where you can see companies saving hundreds of thousands of dollars a year just by making those minor changes. So you can replay data up to 24 hours, 168. Can't say this enough because people are like, Kinesis sounds great. Why don't I just use it as instead of S3? Well, because the answer is we throw your data away. That's why. Whereas it's highly durable HA up to 7 days, and after that case, it's gone. So important. Just don't forget this. Kinesis is a temporary staging area for your streaming data, and that's why all of those pictures we saw before were pulling data out and persisting the data in S3 because S3 is durable and it'll stick around. I didn't mention Glacier, but a lot of people do tiered data. So they do Kinesis for the hottest data, and then sort of standard storage S3 and then infrequent access S3 for like older data, say older than a month, and then Glacier for older than 3 months. Because it turns out you don't need those Apache logs very often, except if you get audited, so you can put them in Glacier and pull them out when you need them later. It's a put interface. There's a few ways to put in, data in, but the important takeaway here is a partition key. So just like a NoSQL database, or just like any kind of data storage, the key of the object that you're putting into the stream determines where it lands in the shard. And this is important for a couple reasons that we'll get into in a second, but that's how on the back end we decide where to put stuff. It's just like an S3. You may not know this, but S3 is essentially kind of the same architecture. It's like a bunch of servers behind the scenes, and depending on the name of your object in S3, we put it in a storage location. We take a hash of the object name, and based on the hash value, we put it in a certain data storage location. So we effectively shard data, or spray the data around different shards. Kinesis is the same, except instead of the object key, you use an explicit partition key in your put. And then you get a sequence number. Now, Kinesis does not guarantee ordering. There is a sequence number, but you shouldn't think of it, if you need like guaranteed sequence, you'll have to use an additional framework like Storm that's really good at that kind of thing. And we'll get into some design patterns, but you shouldn't really think of it as an ordered queue. It's effectively like an unordered queue that doesn't guarantee 100% sort of consistency in order, but there's ways you can get around that. When you're sizing the amount of streams, just think about how much inbound data you need, and think of that 1 megabyte per second metric and then 1,000 TPS. And you should be able to figure it out pretty easily. And because it's pay-as-you-go, it doesn't really matter. You could just add more shards or remove shards later. Don't stress too much about sizing. The time that you spent stressing about sizing is probably translates into money for your company, which could just be invested in more shards. How to size your Kinesis stream? Think about this. So say you have 2 producers, 2 servers with logs, and they're each producing 2 kilobyte records, sort of normal at 500 kilobytes per second. So in this case, you'll need 2 shards, probably more, to be honest, give you a little headroom, but minimum of 2 shards required in this case. Oh, this is 24 hours, this is old. It's actually up to 7 days. But say you have 3 consuming applications for different uses, and we didn't really talk about this, but this was another reason that makes Kinesis kind of powerful, and S3. When you store data in Kinesis, just like when you store data in S3, you can have multiple applications, multiple clusters pointing to the same data set and processing it in parallel. So in this case, you may have payment processing, fraud detection. Your credit card companies are doing this. They're looking not only at processing the payment, but also seeing if there's any irregularities, and they parallelize those things. So you can have multiple things pointing at the same 2 shards. But this is another reason why the egress rate is going to be bigger than the ingress rate, not only for catch-up, but because you may have multiple clusters, multiple applications looking at the same data set simultaneously, and therefore will consume more overall bandwidth. So in this case, if each needs 1 meg, so you'll need 6 megabytes total, so you need to add another shard there. I took away the animation, but there's a little animation that adds another shard. Does that make sense? S3 is the same way. When you store data in S3, you can have a Spark cluster, maybe doing financial analysis for your CFO. You could have like some other thing that's loading stuff into Redshift. You could have some other thing that's running Hadoop with Hive because your guys know SQL for your advertising division. And this saves you a lot of money and complexity because you can have one single source of truth with data, whether it's your streaming data or your S3 data, and have multiple applications looking at the same thing. This is what I wanted to get to, though, is that partition key is important to think about because of ordering. And sometimes it's important to know what order things came in. If you need to do replays of events, for example, to figure out what specific order came to a certain condition in a debugging operation or whatever, you need to know what order they came in. And it turns out sequence numbers across shards is not, it's hard because you have separate shards and different sequence numbers in each shard. It's hard to fully replay that order just using Kinesis itself. So one way you can do it is actually control the partition key, and have the partition key itself represent order. But the problem with that is it'll be kind of serial because you'll have like partition key 1, partition key 2, partition key 3, and then because we take a hash in that partition key and spray into a shard based on the partition key, it'll take 1, 2, 3 and put it in the same shard, and then 4, 5, 6 and put it in the same shard. Whereas just like S3, if you give it a random name, it would spray it around different shards because each hash would be very different because the name is very different, right? It's the same with partition keys. So the way you get around that, if you want to have both, the ability to process unordered very quickly, in order to fully saturate the throughput of all of your shards, but also know what order things came in, this is where DynamoDB could come in. It's a fully consistent data store, so you actually maintain a list of these random partition keys in order in a DynamoDB table. So it involves two writes or 2 API calls, one to Dynamo and one in parallel to Kinesis, but it is a way of guaranteeing sort of order while not sacrificing performance by using sort of a serial partition key. sort of an advanced topic, but I think it's important to plant that seed. So we have a Kinesis agent. If all this sounds kind of hard, then don't do it. We have a Kinesis agent that can put for you. Like I said before, you can use Flume or FluentD. Most people, honestly, are not writing this code themselves. They're using the agent or our libraries, our Kinesis producer library, or some other way to handle all these nuances for them. And honestly, I'd encourage you to do the same, unless you have a really strong reason or to do things like guaranteed ordering or other stuff. Most of us just want to get our data in there and get it out. So use the agent, use Fluent, use Flume, whatever the case may be. It's all well documented on the website. Before we get into actually processing data, just two concepts I want to make sure we all understand. Say you have 3 shards and you move back to 2 shards. We don't squish the shards together. What we actually do is like decommission the 3rd shard, and then you effectively drain that 3rd shard. So it blocks it from additional puts, and then you effectively drain that all the sequence numbers, all the partition keys from that shard. So it's invisible for new writes, but it's still visible for reads. That's what's really happening when we're merging shards. We're not merging shards, we're actually just taking one off and letting you drain that. And likewise, when you split a shard, when you take 2, we call it splitting. And in the mental picture, you think we're just splitting one in half and making it into 3. That's actually not really what is happening. We're adding a new shard, and it's intelligent enough in the back end that that it starts distributing across all 3 automatically because of the partition key and the way it sort of sprays across. So the merge and split is kind of a misnomer. That's why I put it up there. And it's not like you lose the data of the 3rd shard when you go from 3 shards to 2 shards. There is a mechanism there that allows you to drain it. And the mechanism that makes a lot of this easier too is the client library. So I mentioned there's a producer library to put in, there's an agent to put in. Likewise, for pulling out, you don't really have to do this yourself. We have a client library. Now, client library does things like worries about mergings and splittings and all this other stuff. It also worries about the partition keys and iterators, all these things you have to do when you're processing data in a queue of any kind. It's not just Kinesis. So it takes care of all this stuff for you. But importantly, it also takes care of a very important concept, which is scaling out EC2 instances to process this stuff. So what happens if your game is really successful and suddenly you have someone like Taylor Swift tweets about your game and suddenly you go from like 5 users to like 50,000 users in like 1 hour. So you have all this new telemetry coming, your game scales wonderfully. What happens on the back end? Like if there's real-time streaming data processing that needs to happen and you had like one crappy little Python script on an EC2 server that was handling your 5 users just fine, what happens when it moves to 50,000 users? Well, yeah, you can scale out, but then you have to think about the EC2 APIs. You have to deploy your library to process. How do you coordinate amongst all the different instances? Who's talking to what shard? How are you keeping track of the sequence number? How do you know that you're not doing duplicate processing? Suddenly, these are big data problems. So my advice to you is not think about that and use the Kinesis client library, because not only does it handle deduplication, it handles sort of only once processing. It also handles the auto-scaling stuff, the EC2 APIs, and will add new Kinesis workers in the form of EC2 instances on as needed to scale with the size of your Kinesis stream. So if you suddenly have a lot more puts and a lot more shards, the Kinesis client library will actually add more EC2 instances to then go and process that data. And you can set limits so you don't, Taylor Swift doesn't DDoS you in the form of financial bills at the end of the month. But the bottom line is it makes certainly the infrastructure part, in addition to code, a lot easier. And I love this actually because we often talk about the cloud is the merging of infrastructure and code. I think that's mostly bull for the most part, but this is for real. There's a total blurring of the lines between your code and infrastructure. EC2 as servers is no different from processing logic to keep track of iterators and sequence numbers, et cetera. So Kinesis client library, very cool. In reality, though, most people are not even using Kinesis client library. They're using Spark Streaming and Storm and all these higher level frameworks. And guess what? Spark Streaming actually uses the Kinesis client library under the covers. They tell you that deep in the documentation. So, takeaway, if you want to write a streaming data processing framework, use the KCL. If you don't, just use Spark Streaming or Storm or some other higher level framework, because the value you get out, by the way, these frameworks are free, the value you get out of having a customized KCL for most mortals is limited. We want to make this easy for you, so start there and work backwards. Lastly, connector, I talked about this a lot. There are libraries such that Kinesis can talk to other AWS services. For example, Persisting to S3 or DynamoDB. It's a way of taking your data, and we talked about Dynamo a lot earlier. If you want data coming into Kinesis, matching some conditions to then land in a DynamoDB table, you could leverage the Kinesis connector library to write a little thin application that makes a decision based on the content of the data and then pushes maybe some subset of the data into a DynamoDB table if it meets those conditions. And remember, even this, most of you don't have to write. Just use Kinesis Firehose, which guess what? Uses the Kinesis connector library under the covers to talk to S3 and to take your data, to aggregate it, to compress it, and to push it into S3. So I talked a lot about Spark. Most people approach Spark from Scala, and Scala is not easy. And so it appears that Spark is hard, and most people associate Spark with giant clusters and Hadoop. Spark is actually fairly, very easy to get started. And I'll tell you why. There's less lines of code. You can use Scala, but you don't have to use Scala. There's also Python for Spark. You're not locked into Scala, and increasingly there's additional language support for Spark. Really, think of Spark as a more modern alternative to Mapreduce. Think of Hadoop as like the family, and Mapreduce is one way to leverage that cluster to process data, and Spark is a new, arguably much better way to process the data. It makes much better use of in-memory processing. It parallelizes things a lot better. So it's just another application that runs on a Hadoop cluster that is a lot faster than and more flexible than Mapreduce. And Spark is not just one thing. There's Spark SQL, which is a SQL interface. You can use that cluster to use SQL to interact with data. It can talk to S3. There's Spark Streaming for streaming data. There's a graph component to Spark. There's a lot of different projects within Spark itself. But the easiest way to think about it is like a MapReduce alternative, an execution engine, a data processing engine that runs on Hadoop clusters. And with Spark Streaming and Spark in general can talk to Kinesis. It can read from Kinesis streams. It can process data out of Kinesis. And it can write to Kinesis. And it's easy because Scala is confusing at first, but is not verbose. You can write really, like what used to take like huge amount of Java in a custom MapReduce job, you can condense down to a few lines of Scala and run much more quickly on Spark. The good news is you don't even have to do this. You can use Spark SQL and use SQL and still get the advantages of that fast backend. So you can do that select star from my Kinesis stream using Spark Streaming, or Spark SQL rather. In this case, we're using Spark for batch processing or rather just for interacting with the Kinesis stream. We're probably actually, in this case, we're probably using Spark Streaming. But you can do things like windowing functions, et cetera, to pull data out and to persist it to HDFS or to, I don't know why it says HDFS here. Probably what you would normally do is persist it to S3 and then copy it into Redshift from there. There are rare cases where it's better to use local HDFS than S3 on Hadoop clusters. This may be one of them. In the same way in Kinesis, you have sort of workers in the Kinesis client library. You need to scale up both the infrastructure backend and the amount of threads processing the data. It's the same thing with Spark and executors. So using Spark, it has a certain number of executors and corresponding to a certain number of Kinesis receivers. It is effectively a scaling mechanism for processing data at scale in Kinesis and corresponding to the number of shards in your Kinesis stream. That was a mouthful. So your executors is a Spark concept about basically corresponding to the number of cores. That's not entirely accurate because you can tune that. But you can tune all this. Basically, the long story, I guess if I was to distill this all down, is that you can tune how fast Spark can process and how it processes data in a Kinesis stream. So there's a correlation between the amount of data and how you process the data in Kinesis, the amount of executors you're using, and how that's linked to the cores on your cluster, how big your cluster is, how fast it can go. So in this case, we're talking about EMRFS, which is an S3-backed file system to persist or to read and write out of S3. So this is just a really fancy way of saying you can use Spark as a data processing execution algorithm, or sorry, engine, to pull data out of Kinesis, process it. Give you an example. Convert all semicolons in all log files to commas. Or to take a bunch of crazy Apache logs, or I'll give you some crazy logs, Omniture logs. How many of you have ever worked with Omniture logs? No advertising people. Okay, Omniture, familiar with the name. They have like the worst or longest, craziest, most highly changing log format I've ever seen in my life. People have written whole like pig libraries about this stuff. And turns out that one Omniture log does not look like another Omniture log. And if you try to take this stuff and stuff it into a structured database like Redshift or MySQL, everything blows up. So you need something in the middle there that takes all these disparate log formats and inconsistencies, like that weird question mark instead of a comma, and normalizes it and looks for problems with the data, cleanses the data, takes out columns you don't need, and picks out the actual subset of data you need, orders it nicely with commas in between so that you can load it into Redshift and it doesn't blow up. I mean, Spark is perfect for that. It can iterate through a huge amount of data very, very, very quickly, take out pieces of the data. You can think of it like the world's most powerful regex. It can do a lot more, but most of us would have written bash scripts with like sed and regex and regular expressions like Perl, you don't have to do that anymore. You can do it with Scala or Python with Spark, and it happens a lot faster and in parallel on a cluster. Say you have an application that's pushing to Kinesis, and the Kinesis stream can actually trigger events. And if you were listening to Saji before, you know that Lambda is a service that you pay for by the millisecond. You can think of it as like functions as a service. So until now, I've been talking about clusters of EC2 instances that are processing this data, right? And using the Kinesis client library, for example, you push a bunch of data into Kinesis, and then you fire up a bunch of EC2 instances, and they're running the Kinesis client library, and you pull out data. Maybe you don't need that cluster. Maybe you only care about some of the data. So as the data is coming in, to your point earlier, it can fire an event saying, hey, I'm new data, I'm here. And that event can trigger a Lambda function. That Lambda function can maybe do basic normalization of the data. It could maybe load that data into S3 if you don't want to use Firehose. It can maybe make a quick determination, is this data I care about? And maybe 99.99% of the data you don't care about, which is usually the case. And Lambda can dump the data and only push interesting data into your database, saving you money because you don't have to pay for as much storage. So think of Lambda as a very thin, it's not as powerful as a huge EC2 cluster. It's certainly not as powerful as a massive Spark streaming cluster. But for most mortals, it does the trick. And it can be a great shim between, like to do basic data transformation that maybe you don't need a Spark cluster to just replace that comma like I was referencing before. So AWS Lambda is this sort of functions as a service that we have. The Lambda architecture is sort of what we were looking at before, where you tier your data in terms of whether it's hot or cold, and you can push your hot data into DynamoDB, for example, and push your cold data into S3 and Glacier and Redshift for sort of batch processing later. So you have streaming processing with batch processing. That's the Lambda architecture. Now this is apparently a play on Lambda architecture. This is the AWS Lambda architecture to sort of try and confuse you. And all this is that the Lambda architecture is that sort of tiered hot and cold model we were talking about earlier, whereas AWS Lambda is a service. This is a good application, and this sort of illustrates actually a Lambda architecture using Lambda. So here you have Kinesis, data coming into Kinesis, firing events that trigger Lambda functions. Based on the contents of the data or the characteristics of the data, it maybe pushes the batch stuff, the colder data, if you will, to our data warehouse, Redshift, for later processing. It pushes the hot data, maybe something that fronts or rather backs a dashboard, to DynamoDB, and it pushes the really long tail stuff that you don't know what to do with yet, or maybe it's in a format that you need to normalize later using a Spark streaming or Spark cluster into S3. So having, again, this is exactly what I just described, having Lambda as kind of a shim between the different places where you may want to either persist or analyze your data. So Kinesis Firehose, again, makes that putting in easy. So if you have that Lambda architecture, yeah, this is fine, but somebody has to write all these Lambda functions. And what if you don't want to spend your time grappling with like Node, and you know, you're really not used to sort of how Node in general has asynchronous programming model. You'll pull your hair out, I promise. So instead of writing all these Lambda functions, why not just use Firehose? And turns out Firehose is really easy. Let me show you the code. It's easier. Okay. So you asked before about, you know, how much code are we talking about here? How hard is it going to be? Well, this is the complete code that I wrote using Python, like on my lap, like while feeding my child, to push data from a weblog line by line into Firehose. Now behind the scenes, what Firehose is actually going to do for me is, as I push these lines, now this is trivial fake code, okay? I'm the first one to say that. But it's complete. You could take this code and run it with like Python, this code, it would work. And if you had a weblog to read line by line called weblog. And it's going to fake it really. It's going to put a line by line log, just as if you were streaming logs into Kinesis. But what Firehose is going to do is the other 500 lines that I don't need to include here. And that is take the data, buffer it up to a meg, wait 60 seconds, compress it into gzip, persist it into S3. That's a lot of code. And that's a lot of potential error, because if in that time my EC2 instance falls over, I lose that meg of logs, and I may lose forever the threat that the hacker was, you know, because the hacker knows I was using EC2, and they take out that EC2 instance, so they have no trace of their work. Whereas with Firehose, I put it in there, it takes care of all of the buffering, the compression, and putting into S3. And I think looking at code is not always a good idea on the screen, but in this case, I hope it illustrates how many lines of code are not here, and how Firehose makes it a lot easier. Similarly, once we release analytics, I'll have a similar slide that just has some SQL that says like, select Matt from, don't worry, this talk is not over, or is almost over, you know, whatever table. And doing that in Spark would take firing up an EMR cluster, going into the Spark SQL shell, et cetera, a lot of steps, where with Kinesis Analytics, you could just write one line of code in our console and you get the contents from the streams, or from the stream rather. So they say some other stuff here, but that's really what I wanted to tell you today. I threw a lot at you, but I hope at least you understand a couple things, and that's why Kinesis streams, Kinesis Firehose, and Kinesis Analytics eventually are useful, And I hope that you also understand the difference between S3, DynamoDB, Kinesis, and really how it's not as hard as it may initially seem to both put data into Kinesis and pull data out. And most importantly, and this is why it was so good that you asked that question earlier, why it's important to use something like Kinesis to decouple the parts of your application, so that when like the kids at Twitter come out with the next thing, or the people at Spark, all quit and now you have to use the next framework, it's not a big deal. Because all of your data is in Kinesis, getting persisted in S3, and all you have to do is change that middle part in the middle, and it's not as much code or hassle as it would have been otherwise.